next video. This is a little video to show you all everything you need to know about the acceleration physics lab assignment. For instance, let's say we have our classic video. We have all of our data points that we go on through here, and we can see where the ball is going to be. We have our time, x velocity, y velocity, and we even have our system set up in place so that we know what's the meters. Okay, we have all this. Cool. This is about acceleration. In physics, with our class, we're only able to deal with one direction at a time. First, I'm going to deal with the x. So I'm going to add a calculated column. I'm going to call this x acceleration. Unit is meters per second per second. What I'm going to do is I'm going to take the first derivative of this. Click apply. Now, all that with the units are in there. Boom, meters per second per second. It's perfect. Same thing with the y. Add calculated column. Y acceleration. Meters per second per second. First derivative. You just have to remember the first derivative thing. It's a calculus thing. And it essentially means slope. Now, this is what we're going to be using for our data. However, what I'm going to do is for this assignment, we are only focused on one phase of motion. Our equations are only really good for one phase of motion. So what I'm going to do is I'm taking a look through here. I'm using this to scroll, and I have two phases. I have on the way up, and then I have on the way down. What I'm going to do is I'm going to take the data as on the way down. So I'm going to start from here, and this is frame 23. I'm going to take all of my data from frame 23 on downward because that is my last phase of motion. So I'm taking it from frame 23. I select this column. I scroll on down. I'm going to click shift and the number 50, and that gets everything in the row. Because if I just click this cell, I only get that cell. But if I click this row, I get the whole row. Same thing. I'm going to go down here. I'm going to click on number 50. I click shift and click so that everything is there. And then I'm going to right click copy. Now, let's say I don't already have this. I take this right here. Boom. It did not give me my titles. First of all, I'm going to get rid of all these decimal places. This is atrocious. Give me 2. Bang. So this is time, and I need the units in seconds. This is x in meters. This is y in meters. This is x velocity in meters per second. This is x acceleration, I think. Come on. X acceleration, meters per second per second. Then we have y velocity, meters per second. And then we have y acceleration, meters per second per second. Now, with everything that we need, acceleration, we have a bunch of different acceleration values. However, in this class, we are only dealing with acceleration in if it is constant, which means that we need to take an average. So I'm going to write down in this x acceleration column, I'm going to write down here x or average x acceleration. Down below, I'm going to click equals, and it says sum. I don't want sum. I want the average. Average of here. I'm going to click on this cell, and then I'm going to click shift and click and take the average of all those numbers. And if you take a look, it says E2 colon E29. That's how you select the range. Boom. Just like that. I'm going to then do average y acceleration. Same thing. Equals, oh, it already knows that I wanted to do that. Average equals average G2 colon G29. Click that. Boom. Now, another part of the assignment is I need to figure out the G's of this acceleration. So what I'm going to do is I'm going to click average. Average X acceleration. Well, that's the bell. And I'm going to put in G this time. Up here, I'm going to put it in meters per second, which it was. And then down here, I'm going to put it in G. And what I'm going to do is I'm going to, in order to do this, all I have to do is I have to click my X acceleration, divide it by 9.8. And that is going to give me my acceleration in G's. I'm going to take it down to 2 decimals. Whoa, it's 0. Interesting. Now, same thing, average Y acceleration, but in G. And same thing, I'm going to take this cell up here, this one acceleration that represents all my Y acceleration. I'm just going to divide it by 9.8. Boom. And that gives me this. I'm going to take down all the different decimals down to just 2 decimals. And now we're in a good spot. Okay, so these are my accelerations. Now, the data that I need in order to create a proper acceleration column, acceleration problem, I need A, I need VF, I need VI, and I need a delta T. Now, for my A, I'm going to pick only one of these. And I'm going to pick the one that is most relevant to my problem. So in this case, I have 0.03. That's not really relevant. In fact, it's no G's. This one, on the other hand, we have mostly all Y acceleration. So I'm going to put negative 5.34 as my acceleration I'm dealing with for my problem. Then for my VF, what I'm going to do is since I'm dealing with Y acceleration, I'm looking at my Y velocity, right? And VF is going to be the last one. So this one, 5.06, I'm going to go ahead and highlight that one right there just so I can remember it. We have negative 5.06. Up here for the initial, I'm taking a look at the initial velocity that I have, and we're going to highlight that one, and my initial velocity I have is negative 0.14. Now for my difference in time, what I will do is I will take a little formula to take advantage of this, equals my final time minus my initial time. And this is now going to be the delta time that you use for your problem. If you have the A final velocity and the initial velocity and the delta time, you have enough to make an acceleration problem. The thing is, remember, as my requirements for the assignment, this is all in meters per second or in SI units. You are going to have to convert this into miles per hour in order to create the type of problem that we need, which was the same example as we had seen in our homework from before, where unit conversions are required. That should be enough of an intro to get you started on this. Have a wonderful day.